Part 3. Part 3. That is calculus. Okay. Wait, this was chapter 8, right? Well, if I'm not wrong, this was chapter 7. Wait, did we miss something? Wait a second. I feel like we missed something. Differentiation, integration, further calculus. Right. Just want to check. 6, 5, 3 chapters here. Wait, I just want to make sure something. So, this is 4, this is 3, and calculus in itself is 1, 2, 3. What are we missing? It's 1, 2, 3, 4, 5. Further calculus, differential equation. Oh, this is 4. My bad. This is 4. Right. This is 4. So total is 11. Right. So okay. Um, chapter 8, 9, 10. I'll do it together. Sorry. Um, chapter 8, 9, 10 is differentiation, calculus, and further calculus. Okay. All right. So let's get down to differentiation. In differentiation, we have the product rule. The product rule, that is d by dx uv u dv dx plus v du dx. The quotient rule, which is dx u by v square v du by dx minus u dv by dx. Then we have the exponential rule, which is actually let's do it differently. Chapter 8, just do differentiation. Okay. Differentiation plus further calculus. All right. So the exponential rule is d by dx. Okay, so d by dx e to the power x is equals to e to the power x d by dx e to the power ax plus b is equals to a e to the power ax plus b, and d by dx. This is going to be very boring because I just have to write down the formulas that you guys are going to work with. Fx e to the power fx. Then logarithmic function. If you guys want, you guys can just fast forward this section because, to be honest, it is going to take some time. Then d by dx ln x plus b, a by x plus b, and differentiation of ln fx is equals to f inverse x by f prime x fx. Okay. Right. Trigonometric functions, which is d by dx of sine x is equals to cos x, d by dx of cos x is equals to minus sine x, d by dx of um, sine x plus b is equals to a cos x plus b. Then d by dx of cos x plus b is minus sine x plus b. D by dx of tan x is equals to sec square x. D by dx of tan ax plus b is a sec square x plus b. Now, uh, now we'll move into what's actually the further calculus part of this chapter. So, d by dx for tan inverse x is 1 by x squared plus 1 squared, which is equals to 1 by x squared plus 1. D by dx for tan inverse ax is equals to 1 by, sorry, that would be a by x squared, sorry, x squared plus 1 squared. All right, now some word example. Feel like I should give an example for this. Example for, say, d by dx of tan inverse x minus 2. Okay, that would be, that is equals to 1 by x minus 2 whole square plus 1 square, and then the differentiation multiplied by the differentiation of x by x minus 2. Actually, why did I write it below? I should write it at the top. Nice. Okay. This is equals to um 1 by x square plus x minus 2 whole square by x minus 2 whole square multiplied by x minus 2 multiplied by 1 minus x 1 by x minus 2 whole square, which is equals to x minus 2 whole square by x square plus x minus 2 whole square times x minus 2 minus x divided by x minus 2 whole square cancels out, which is equals to x minus 2 minus x by x square minus 2x plus 2. So x are cancelled out. We get minus 2 by x squared minus 2x plus 2. That's the answer for the differentiation. Actually, since we did this and all, might as well take this and put it at the top. Nice. This looks better. Oh, this generally looks way better. And I think I can take this example and place it here. All right. Okay. Now, chapter 9. Okay, guys. I just checked, and the integration part of the video was kind of corrupted. So yeah, I did go a bit far, but no worries. I'm just gonna explain it. Okay. So on the left-hand side, I wrote all the formulas that you need for integration, and in the right-hand side, there are some special cases. So let's go through them. Okay. So in differentiation, there was just one or two types of special case that I had to show you guys. But in integration, I have to show you guys a bit more. Okay, so xn dx is x to the power n plus 1 by n plus 1 plus c. Integration of dx is x plus c. Integration of e to the power x is e to the power x plus c. Integration of e to the power ax plus b is 1 by a to the power ax plus b plus c. 1 by ax dx is ln x. 1 by ax plus b dx is equals to 1 by a ln ax plus b plus c. Integration of cos x dx is sin x plus c. Cos x ax plus b dx is 1 by a sin ax plus b plus c. Integration of sin x dx is equals to minus cos x plus c. Integration of sin x ax plus b dx is equals to minus a cos ax plus b plus c. Integration of sec square x dx is equals to tan x plus c. Integration of sec square ax plus b dx is equals to 1 by a tan ax plus b plus c. Integration of cosec x cot x dx is equals to minus cosec x plus c. Integration of sec x tan x dx is equals to sec x plus c. Integration of cos x square is minus cot x plus c. Integration of sec x is ln sec x plus tan x plus c. Area is integration of your function that is given, or integration of y. Volume is pi integration of y square if it's about the x-axis, and finally volume is equals to pi integration of x square if it's about the y-axis. Now, the most new formula that we learned in A2 is integration by parts, where u v dx is equals to u integration of v dx, integration whole brackets derivation of u integration of v bracket close the total integration dx. So, of course, very confusing, right? But you will apply these formulas once you start solving the question paper, and most of them are given in your data booklet. However, there are still some special cases that you have to learn in A2 for integration, because A2 integration actually makes up about 15 to 20 marks. Okay? All right. So let's start. Number one, how to choose U and V during integration by parts. We choose U and V using Lyot rule. L is logarithm, example ln x or ln 2x. I is inverse trigonometry, example tan inverse x, sine inverse x. A is algebraic, example x squared to x squared comma 2x. T is trigonometry, example is sin x tan x. E is exponential, example is ex bracket comma e to the power x plus 5, like whatever. It has to be exponential function. So example maths. Number one, the ln problem. Ln problem is, let's say integration of okay, there I'll give you two examples for the ln problem. So let's say integration of cot theta d theta. We can say cot theta is equals to cos theta by sine theta d theta. Now, if we differentiate sine theta, we get cos theta. Now, as the derivative of the denominator is equal to the numerator, we can say integration of cos theta by sine theta ln sine theta. Okay, what this basically means is, give me a second. So this basically means, this basically means numerator is cos theta is equals to, okay. So the derivative of the denominator, so the derivative of sine x is cos x is equal to numerator, which is the cos x. Okay. Example 2. X square by x integration of x square by x cubed plus 4 dx. So d by dx is x cubed plus 4. D by dx of x cubed plus 4 is 3x square. Now we have to make the numerator 3x square. So if we multiply a 3 at the top, we have to make sure that we also divide 1 by 3, using 1 by 3. Okay. Hence, wait, right. Yes. Hence, this becomes 1 by 3 ln x cubed plus 4. Then integration using partial fractions. So this is an example math. We have to show that integration of 2x plus 7 by 2x plus 1 into x plus 2 for limits 0 to 7 is equals to ln 50. First, what we do is first we do partial fractions. So the partial fraction is the function, and which is the function is, we can solve this by saying 2x plus 7 by 2x plus 1 into x plus 2 is equals to a by 2x plus 1 plus b x plus 2. So 2x plus 7 is equals to a 2x plus 2 a x plus 2 plus b 2x plus 1. So if x is equals to minus 2, b is equals to minus 1, and when x is equals to 0, a is equals to 4. So we integrate this using so we split it into fractions, and finally we when we integrate it we get 2 ln 2x plus 1 minus ln x plus 2. So if you just insert the values, we can see that we get the answer ln 15, which is shown. Finally, this is the big this is wait, 2. Yeah. Okay, this is one of the bigger ones actually. This is integration by substitution. So first, substitute. Okay, let's say, okay, this is the question. Okay, this is the, right, this is the question. Substitute, right, I'll just this is the example question. So substitute x is equals to 2 tan theta to show that this function can be written as this. Okay, can be written as this, and then we have to find the exact value. Exact value means no decimal at all. Okay, step one, finding the limits. Upper limit, when x is equals to 2, 2 is equals to 2 tan theta is equals to 1, theta is equals to pi by 4. Does it match? Yes, it matches with our pi by 4. Lower limit, x is equals to 0, 2 tan theta is equals to 0, theta is equals to 0. Does it match? It matches because our lower limit is theta in this case. Finding dx. So dx by d theta is 2 sec squared theta. Dx is equals to 2 sec squared theta into d theta. Now we have to substitute everything. So first, let's write our limits. Our limits are pi by 4 to 0. Okay, integration 8 by 4 plus, instead of x squared, we have to write 4 tan square theta, and then you have to put bracket whole square, multiplied by, instead of dx, we learned that dx is equals to 2 sec square theta d theta, right? So we write that instead of instead of dx. Then we take common. If we take 4 or if we take 4 square common, we get 1 plus tan square theta, and we know that sec square theta can be written as 1 plus tan square theta. So we cross out whatever can be crossed out. Then we get 1 by sec square theta, which is equals to which can be written as integration of cos square theta d theta, shown. Now finding the exact value. So again, we take this, and okay, we know that cos square theta can be written as half 1 plus cos 2 theta, taking half common and integrating it, we get 1 becomes theta and cos 2 theta becomes sine 2 theta by 2. Then we insert the values to get pi by 8 plus 1 by 4. So this is how it is done, right? Okay, now, right, guys, so our next example our next example is, or oh, sorry, excuse me, number 4, which is integration by parts. Integration by parts. Okay, now let's start. So again, to start with example question, that is uh pi, so 0 to pi x square sine x dx is equals to pi square minus 4. So according to Lee 8, we know that this is algebraic, this is trigonometric. So we can say u is equals to x square, v is equals to sine x. Okay, now solve it. X square sine x dx minus d by dx of d by df of x square integration of sine x dx total dx. Then we get minus x square cos x minus 2x minus cos x dx. What we can do is we can take the minus forward. So x squared cos x plus integration 2 cos x 2x cos x. Now, do you guys see a problem? This is also in the UV format. So what we have to do integration by parts again. Okay? So keep this constant. We'll carry forward it in a bit. So we know u is 2x, v is cos x. Right. Therefore, 2x cos x dx minus d by dx 2x integration of cos x dx whole dx. This becomes 2x sin x minus 2 sin x dx. 2 sin x dx can be written as uh, cos x, right? Minus 2 cos x. Sorry, no more dx because we have integrated it already. So it becomes 2x sin x plus 2 cos x. Okay, now we have to bring this back down, and therefore we can write minus x squared, excuse me, yes, minus x squared cos x plus 2x sin x plus 2 cos x pi 0. So we can get pi square minus 2 or minus 2, which is pi square minus 4. That is show. I did not manually input the values here, guys, because it takes a lot of time, but you guys should be able to do it by now. Right. So that's all of integration. No, I think I have to move this example up now. Right, right. Let me fix this. I want to say that is all of integration, but that is also not all of integration because there are a few key things that I did not share with you guys, which I am going to share in just a bit. Okay, wait. So, guys, there are 3 more formulas for integration, which I am going to show you. That is, okay, integration of 1 by x squared plus a squared dx is equals to sorry, 1 by a tan inverse x by a plus c. This is one. Next is 1 by x squared minus a squared, which is 1 by 2a ln x minus a x plus a plus c for x is greater than a. And this one is 1 by a square 1 by 1 by a square minus x square dx is equals to 1 by 2a ln a plus x by a minus x, where modulus of x is less than a. Now, the thing is, I will show you example for only this one. This and this are very, very rare. Came only once. These two formulas came only once in the last 5 years. These two formulas were even added from 2019. So you guys don't have to worry about this. So yeah, and actually there's actually one more formula, whose case example I'll also show you. That is integration of f inverse x into fx to the power n dx. Okay, in which u is equals to fx, v is equals to f inverse x. Wait, actually give me a moment. Uh, this is actually an integration by parts. Integration by parts formula. Also, you guys also don't have to worry about this because this also came once, or I think twice, 2 times in the last 5 years. Okay, let's okay. Then let's start from here again. Let me show you guys an example for oh you could say the last four formulas are sorry, the last five formulas are part of the further calculus of integration. Okay, all right. So example for for integration of 1 by square integration of x square x square plus a square. Okay, right. Now that would be okay. That would be let's say integration of 1 by 2x square plus 3. Okay, the example. So what do we write? We say 1 by 2. Okay, first 1 by 2, 1 by x square plus 3 by 2. So we brought it in the 3x square plus root 3 by 2 format. Okay, then we can say that 1 by 2, we can write it as x whole square plus root of 3 by 2 whole square. Right, then you can forward and write 1 by 2 multiplied by 1 by root 3 by 2 tan inverse x by root of 3 by 2. plus c. Then we can write 1 by 2 times 2 by 3, sorry, root 2 by 3 tan inverse root 2 by 3 x plus c. Just write, yeah. Okay, so that is the answer for this. Now I want to show you guys. Okay. Um. Actually, number 3. Still not. This is number 3. Okay. Before I go show you guys something, there are 2 notes that I think I want to write for differentiation. Should I write? Hold up. Note is wait. So when asked to find coordinates, if question says number 1, tangent is parallel to x-axis, therefore dy by dx equals to 0. If tangent is parallel to y-axis, the denominator dx is equals to 0. That's how you do it. So that's one more thing that I wanted to add, and I'll move for the example. Okay, guys, hopefully this is the final example for okay. Okay, so f inverse x fx power n dx. So this is the example for this unique integration by parts formula that is nowhere given in our data booklet nor shown in any mark scheme. But yeah, okay. So the math that we have taken is actually from a question paper. Okay. So the example math is from 9709 32 October November 25. I would like you guys to open up this question paper and go to question number 8B. So in 8A, it's already given. That sine 4x is equals to, wait, how much was it again? Give me a second, guys. Right. Yes, sine 4x is equals to 4 sine 2 cos cube x minus cos x. Okay. Now I will pick up the pace. All right. So what are we told? We are told in question 8b, find exact value of pi by 4, 0, cos cube x sine 4x dx. So what's our first step? Step 1. First step is write the question, rewrite the question. Rewrite the question, actually rearrange the question. So we can say cos cube x multiplied by 4 sine x, sorry, that's 4 sine x into 2 cos cube x minus cos x dx. Now, this is step 1, right? Then we can write pi by 4, 0. We can just say this is 8. If we multiply everything together, we'll get 8 sine x cos 6x. Sorry, I will, cos to the power 6x. Cos to the power 6x minus 4 sine x cos to the power 4x dx. Now, of course, I have this done in my copy, but you guys should expand it by yourselves. You understand. Now, step 2, finding limits. No, yeah, finding limits. Now, this is rewriting the question. Okay, finding limits. So, when x is equals to 0, u is equals to cos theta, which is equals to 1. Right. When x is equals to pi by 4, u is equals to cos. Oh, wait. I'm sorry. Okay, no. I'm sorry, guys. Sorry. Oh, wait, this was not step 2. Sorry. I forgot step. This is step 3, actually. So, now, we know that anything with the power is fx, and anything with not the power is f inverse x. So, this is fx to the power 6. This is fx to the power 4. And this is f inverse x. This is f inverse x. Right. So, step 2 is finding u and v. So, u is equals to cos x, v is equals to sin x. All right. Then our next step is to find step 3. Find dx. We have to find a substitution for dx so that we can place it in our substitution. So we can say du by dx is equals to minus sine x. Right. So du is equals to minus sine x dx. Okay, minus sine x dx. All right. Now, step 4, finding. You could write du, or you could also write dx is equals to minus du by sine x. Like whichever one you think will work for you, whichever one makes it easier for you to cancel things out. Okay. Then finding limits. So for x is equals to 0, u is equals to cos 0, which is equals to 1, for x is equals to pi by 4, u is equals to cos pi by 4, which is equals to root 2 by 2. Finally, step 4. So finally, step 5. Step 5. Substitute everything. Now, we can write root 2 by 2, 1. 8 u to the power 6. Now that we know that um du is equals to minus sin x dx. So what we can do is we can write so we can say and also say that take this. We can say minus du is equals to sin x dx. All right. So you can say minus du minus again root 2 by 2 1 4 u to the power 4 minus du. It's better if you guys break it into two integrations, okay? So that makes things easier. Okay. Now, did you guys know something? I'm glad this sum has this. You guys can change limits. Actually, wait, give me a second. Oh, okay. Okay. So the lesson that I was gonna give you guys is if you have a minus with your integration. Now, if you guys want this minus to disappear, there are two ways to do it. One, you could write root 2 root 2 by 2, 1 minus 8u the power 6 du. That's one way. And the other way is the other way you could reverse the limits. Okay, you could reverse the limits and write a to the power 6 du. So keeping negative with constant and reversing limits. Uh, this is one thing that I want to teach you guys, but it's a side note. Okay, treat this as a side note. Anyways, so moving forward, what I will do is I'll just keep it as it is. Uh, it. So I don't want much hassle. So I'll just do the integration. By the way, I'm using this. Okay, I'm using the first method. I'm keeping negative with the constant. Okay. All right. So we get minus 8 u to the power 7 by 7 for the limits root 2 by 2 1 plus 4 u to the power 5 by 5 root 2 by 2 1. Now minus 8 by 7 8 root 2 sorry 8 root 7 this should be root 2 by 2 to the power 7 minus 1 to the power 7 plus, again, taking this constant common, we can write root 2 by 2 to the power 5 minus 1 to the power 5. Okay. Then we should multiply. Okay. We should multiply again. Uh, so minus 8 by 7. Okay, okay, do not press root 2 by 2 to the power 7 in your calculator because you'll get a decimal. Instead, manually just do root 2 into root 2 into root 2 7 times to get 8 root 2 by 128 minus 1 plus 4 by 5 4 root 2 by 32 minus 1. Then multiply the constants. So if you multiply the constants, we will have minus 1 by 14 root 2 plus 8 by 7 plus 1 by 10 root 2 minus 4 by 5, which we can later we can add this and this and add this and this. Hence we get hence we get 1 by 35 right, 1 by 35 root 2 plus 12 by 35. Now you could keep it like this, or you could further simplify it and write the answer as 1 by 35 root 2 plus 12. That's it. That's your answer. Oh my God, this was so big. I think I should take step 4 a bit above, considering we still have differential equation left. Wait. Actually, yeah, we don't have much space. Yeah, nice. I'm so sorry for making it so messy, guys, but there is literally nothing I can do. It's a very, very hard topic to teach if you're trying to break things down. So that's all. Now we can move on to chapter 10. Chapter 10, that is differential equations. Okay. Again, for differential equations, I would also like to start with an overview. Because okay, I won't give you guys so much of an overview, but you'll see. So what does differential equation mean? It means separating variables. Okay. General formula is f fy dy by dx or gx. So integration of fy dy is equal to integration of gx dx. Okay. So notes are solve to find, oh, yeah. Solve to find. Okay, no. Oh yeah. Therefore, y is equals to x plus c. Right. So solve to find a general solution. Substitute values to obtain a particular result. And finally, answers can be checked by differentiation. Usually the math are so complicated in differential equation that it becomes very, very hard to check with the differentiation. So most people usually just don't bother doing it. Anyways, I'll start with example math. I'll give you guys an example math. Okay, let's say x and t satisfy the differential equation 3x plus 2x cubed dx by dt, which is equals to k 3x squared plus x to the power 4, where k is a constant. Where k is a constant. So when t is equals to 0, x is equals to 1, and when t is equals to 0.5, x is equals to 2. Show that 7 2t is equals to 3x squared plus x to the power 4 by 4. This is one of the hardest differential equations that I found. Of course, there are harder ones. This is very tricky. So let's do it. Okay. I think I'm going to use a different color to solve this. Let's use magenta. So 3x plus 2x cubed dx is equals to k 3x squared plus x to the power 4. So let's take all the x's together. 3x squared plus x to the power 4 dx is equals to k dt. Now, what we can do is 3 plus 2x squared x 3x plus x cubed um dx, which is equals to k dt. Now, partial fraction. We have to partial fraction this. I won't show you guys because it's gonna take long, but you guys will arrive something at 1 by x plus uh actually I made a mistake. It should be x squared 3 plus x squared. So yeah, okay, partial fraction this, you'll get 1 by x plus x by 3 plus x squared dx is equals to k dt. So integration, right. Okay. Now we will get ln x plus ln x plus half ln 3 plus x squared is equals to kt plus c. Now we multiply this how, so we take this 2 to the other side. So it becomes 2 ln x plus 2 ln x plus ln 3 plus x squared is equals to 2kt plus c. Let c be constant, okay? Don't write it 2c, okay? Just because if you okay, all right. What's okay? Why did I not write 2c? So 2 into c is a constant, right? Instead of writing c, you can just write c. Okay. Because at the end of the day, you could write 2 into 5 is equals to, okay, let's say c is equals to 5. Okay. Okay, let's say c is equals to 5. So 2c is equals to 10. So can we just not write 10 is equals to c? Simple, right? Don't sweat it. Just know that you don't have to multiply or divide anything with c. Let c be as it is, and let c be in one side only. Okay? All right. Sorry, where was I? Okay. Now what we have to do is we have to find the value of c. Therefore, find c. Now we know for x is equals to 1, or for t is equals to 0. T is equals to 0. And just use this, so we can say ln 1, 2 ln 1 plus ln 4 is equals to c. C is equals to ln 4 because ln 1 is equals to 0. Okay? All right. Then we can find k. All right. Now finding k. Next, find k. So, for k, we can say that x is equals to 2, t is equals to 0.5. Okay. Then 2 ln 2. Wait, give me a moment. Oops, sorry, I made a mistake, guys. Okay, so not a big one. Anyways, so we can say 2 ln 2, 2 ln 2 plus ln 7 is equals to k plus ln 4. Now 2 ln 2, it can also be written as ln 4 plus ln 7 is equals to k plus ln 4. Cross this out. Therefore, we get k is equals to ln 7. Now, we have to find the equation, right? So we can say ln x squared plus ln 3 plus x squared is equals to 2t ln 7 plus ln 4. Now, ln, we can write ln, okay, now, actually, you guys might be confused. So yeah, 2 ln x, so we can say 2 ln x squared plus ln 3 plus x squared is equals to 2t ln 7 plus ln 4. Oh, no, wait. Minus ln 4 is equals to 2t ln 7. Now we can bring the lns together. So 3x squared plus x to the power 4 by 4 is equals to ln 7 2t. Ln cancels out. Therefore 7 2t is equals to 3x squared plus x to the power 4 by 4, which is shown. Nice. Now, for another example math, I will be taking this one from the book. Example math 1. Okay. Example math 2. Okay. This is differential equation word problems. The question that I have taken is from exercise 10B, number 13. The last and most probably the hardest math. Now, before we get started, I'd like to give you guys a note. That is, word problems given where differential equations have to be formed in order to find quantities from a general solution. All right. So let's do the math. Actually, I'm going to take this from here and put it here. Simple. Okay, let's do it. So 13a, it says dn by dt is proportional to n. So we can say dn by dt is equals to kn. So we can say 1 by n dn is equals to k dt. So you can say ln n is equals to kt plus c. At t is equals to 0, ln 5000 is equals to c. Therefore, ln n is equals to kt plus ln 5000. Right. Then at t is equals to 3.5 hours, ln 1 million is equals to 3.5k plus ln 5000. This is basically, if you guys didn't understand, this is finding k, and this step is finding c. Okay, so yeah, on 5000, so we get ln 200 is equals to 3.5k. K is equals to 1.5138. Therefore, ln n is equals to 1.5138t plus ln 5000. Okay. At doubling time, n is equals to 2n, which is equals to 2 into 5000, which is equals to 10,000. Right. So therefore, ln 10,000 is equals to 1.5138t plus ln 5000. We can say ln 2 is equals to 1.5138t, and answer is t is equals to 0.458 hours. Okay, so that's all. that is everything for differential equation that I want to teach you guys, and most probably everything for uh, everything that you guys have to know for your entire P3 syllabus. I will lastly just go over 2 or 3 extras, and then we'll finish this video off. Okay. Extras. All right. Right. So our next graph that we're gonna draw is the tan x graph, which looks like this. Y x. Now we'll have pi by 2, pi, 3 pi by 2, 2 pi. Now every okay. Now dotted lines on this. Okay. Okay, so the graph looks like this from base. And here. This is basic tan x graph. Nice. Okay, what else? So, 2. This is of course 3. This is 4. Now, the fifth graph that you guys made now are the simple graphs. Okay. Okay. This is y is equals to x cubed. Note that, oh, excuse me. Wait. All right. So, uh, there is no point of intersection. There is no point of intersection. Okay. There's only point of inflection at 0, 0. Okay. Our next graph is okay. 6. All right. These are graphs. I'm drawing these graphs to actually give you guys a good idea. Okay, this is the, okay, watch this. So this is a quadratic graph. A, sorry, this is X, Y. Okay, this is A, this is B, this is C, this is the y-intercept. So this graph has the equation x plus A, x minus B, x minus C, also known as the Cubic graph. Cubic graph. Then, then we have number 7, which is okay. This is the inverse graph. Okay. So this is sometimes I don't understand how this tablet works. Okay, this is 1 and this is 2. This is okay, this is actually a bad sketch. This is a better sketch. Okay. Y, X. This is Y is equals to 1 by X graph. And then, okay. Uh, let's take number 8. Now, this is exponential graph. Say this is so this is 1. This is Y is equals to e to the power X. Similarly, this is Y is equals to e to the power minus X. This is exponential graph. Exponential graph. Okay, note that graph becomes steeper as value of A increases. Nice. Then we have the log graph. This is number 9. Y, X. So this is 1. Okay, this would be, excuse me. This is Y is equals to log X. Okay. Now to just add a few basic details to all the graphs that we have drawn. Nice. And ending off with a note. Note. The asymptote line is on the value for which the equation is an error. Example, for 0 ln x, that is ln 0 equals to error. For y is equals to ln x plus 1, asymptote line is -1 because x plus 1 is equals to 0, x is equals to -1. Okay, with due time, you guys will understand my notes while doing solving questions by yourself. This is mostly required for numerical solutions. Now, extra things that I'd like to add are note. Okay, that is a few things to note from me are okay. Right. 1 by infinity is equals to 0. E to the power minus infinity, which is 1 by e to the power infinity, is equals to 0. Uh, what else? Then, when thinking of quadrants, let's say positive quadrants, many students face difficulty. So this is the positive quadrant. At the top, 0, pi by 2, pi, 3 pi by 2, and 2 pi. Okay? Sin x, cos x, tan x, sin x, tan x, cos x. Okay, then negative quadrant. This is where students face difficulty. So the negative quadrant, you have to think like this. So minus pi by 2, 0. This is minus 2 pi minus 3 pi by 2. Okay, so that's that. That's how you think. All right. In which this is true for sine, cos, tan. This is true for sine x. This is true for tan x, and this is true for cos x. Oh, okay. Right. Is there anything more that I'd like to add? No. But there are two more things. Okay. Extra for differentiation. This is an extra concept for differentiation that you guys, I think, should know. Okay. This is what I like to call it. Finding whether a point is minimum slash maximum. Okay. Now, now we know. So let's say a question. Okay. Question. Let's say it's given equation of a curve y is equals to x e to the power 1 minus 2x. A. Find the coordinate of stationary points. So most people solve this very easily. They know that dy by dx, they find dy by dx, which is e to the power 1 minus 2x minus 2 e to the power 1 minus 2x. Then equating this to 0, e to the power 1 minus 2x, 1 minus, uh, sorry, this is 2x, 2x. Therefore, x is equals to half, y is equals to a half. Okay, now separately, part B will ask, determine whether the point is maximum or minimum. Now, what most people do is they find the second derivative. So, two options. You can find, oh, this is 2 marks. Let's say for 2 marks. So what you can do, you can find second derivative, which is d square y dx square, or graphical representation. Too long. So I'm going to show you guys uh, the graphical representation. So how do we do this? So put this here. We draw a table. I draw a table. So we know the stationary point was at x is equals to 0. This is d by dx, dy by dx. This is x is less than half at x is equals to half. And finally, x is greater than half. When x is equals to half, dy by dx is 0. When x is when x is uh when x is less than half, let's a value use x is equals to 0.4, then we get dy by dx is negative. And if we use x is equals to 0.6, we get dy by dx as a positive value. You can check this. And then finally, there's one more. We have to draw another segment of this table. We call this shape. Shape of curve. Now, if the curve, sorry, my bad, I made a mistake. Sorry. This would be positive, this would be negative, right? So, if the curve has a positive gradient, shape is like this. For stationary point, shape is this. For negative gradient, shape is like this. Therefore, we can deduce the shape of the graph is like this, which is a maximum curve. Therefore, we can say point is maximum. Okay, that's it. Okay, guys, that's all for today. I don't think I have anything more to teach. These are all the concepts that you guys will be needing when you guys start solving your question papers. And of course, there are unique cases that you'll find here and there, but I think I have taught you guys the most common, the most complex, and the most required concepts that you guys need. With this, I am, wait, should I wait, am I forgetting something? No, I don't think I'm forgetting anything. Uh, with this, I conclude this video, and I hope to see you guys in the next one. Inshallah, take care. And if you guys have any queries, please you can always uh write a comment down below or reach me via mail. Thank you. Take care. Inshallah. Bye bye. Inshallah, you'll do good. Bye. Okay, guys. This is the final segment of this video. Uh, okay. So these are graphs to know. These are some of the graph sketches that you are to learn. I will show you guys the general sketch, okay, for each type of graph. Okay, let's take it nice and simple. Actually, not this. Okay, okay. So, uh, number one, you have, of course, straight line, which is y is equals to x. This curve is known as y is equals to x squared, and the downward curve is y is equals to root of x. Okay, then you're required to know the cosine graphs or the sinusoidal graphs, which are, draw them. Right, hold up. So let me label them as well. Y, X, Y, X. So this is one, this is one. Should be your P. Okay, so this is, of course, pi by 2, pi, 3 pi by 2, 2 pi. Of course, from -1 to 1, this is y is equals to sine x. Next, you're required to know the cos x graph. Very simple. X, y. Okay. So, one, so is -1. Uh, this is pi by 2, pi, 3 pi by 2, 2 pi. Okay, all right. Uh, y is equals to cos x. Then, right. So, our next graph that we're gonna draw is the tan x graph, which looks like this. y, x. Now we'll have pi by 2, pi, 3 pi by 2, 2 pi. Now every, okay, now dotted lines on this. Okay. Okay, so the graph looks like this from base. And here. This is basic tan x graph. Nice. Okay, what else? So, two. This is of course 3. This is 4. Now, the fifth graph that you guys made now are the simple graphs. Okay. Okay. This is y is equals to x cubed. Note that, oh, excuse me. Wait. Right. So, uh, there is no point of intersection. There is no point of intersection. Okay. There's only point of inflection at 0, 0. Okay. Our next graph is, okay, 6. All right. These are graphs. I'm drawing these graphs to actually give you guys a good idea. Okay, this is the, okay, watch this. So this is a quadratic graph. A, sorry, this is X, Y. Okay, this is A, this is B, this is C, this is the y-intercept. So this graph has the equation x plus A, x minus B, x minus C, also known as the cubic graph. Cubic graph. Then, then we have number 7, which is, okay, this is the inverse graph. Okay, so this is, sometimes I don't understand how this tablet works. Okay, this is 1, and this is 2. This is, okay, this is actually a bad sketch. This is a better sketch. Okay. Y, X. This is Y is equals to 1 by X graph. And then, okay. Uh, let's take number 8. Now, this is exponential graph. Say this is so this is 1. This is Y is equals to e to the power X. Similarly, this is Y is equals to e to the power minus X. This is exponential graph. Exponential graph. Okay, note that graph becomes steeper as value of A increases. Nice. Then we have the long graph. This is number 9. Y, X. So this is 1. Okay, this would be, excuse me. This is Y is equals to ln X. Okay. Now to just add a few basic details to all the graphs that we have drawn. Nice. And ending off with a note. Note. The asymptote line is on the value for which the equation is an error. Example, for 0 ln x, that is ln 0 equals to error, for y is equals to ln x plus 1, asymptote line is -1 because x plus 1 is equals to 0, x is equals to -1. Okay, with due time, you guys will understand my notes while doing solving questions by yourself. This is mostly required for numerical solutions. Now, extra things that I'd like to add are note. Okay, that is a few things to note from me are okay. Right. 1 by infinity is equals to 0. E to the power minus infinity, which is 1 by e to the power infinity, is equals to 0. Uh, what else? Then, when thinking of quadrants, let's say positive quadrants, many students face difficulty. So this is the positive quadrant. At the top, 0, pi by 2, pi, 3 pi by 2, and 2 pi. Okay? Sin x, cos x, tan x, sin x, tan x, cos x. Okay, then negative quadrant. This is where students face difficulty. So the negative quadrant, you have to think like this. So minus pi by 2, 0. This is minus 2 pi minus 3 pi by 2. Okay, so that's that. That's how you think. All right, in which this is true for sine, cos, tan. This is true for sine x. This is true for tan x, and this is true for cos x. Oh, okay, right. Is there anything more that I'd like to add? No, but there are two more things. Okay. Extra for differentiation. This is an extra concept for differentiation that you guys, I think, should know. Okay, this is what I like to call it. Finding whether a point is minimum slash maximum. Okay, now, now we know. So let's say a question. Okay, question. Let's say it's given equation of a curve y is equals to x e to the power 1 minus 2x. A, find the coordinate of stationary points. So most people solve this very easily. They know that dy by dx, they find dy by dx, which is e to the power 1 minus 2x minus 2 e to the power 1 minus 2x. Then equating this to 0, e to the power 1 minus 2x, 1 minus, uh, sorry, this is 2x. 2x. Therefore, x is equals to half, y is equals to half. Okay, now separately, part B will ask, determine whether the point is maximum or minimum. Now, what most people do is they find the second derivative. So, two options. You can find, oh, this is 2 marks. Let's say for 2 marks. So what you can do, you can find second derivative, which is d square y dx square, or graphical representation. Too long. So I'm going to show you guys uh, the graphical representation. So how do we do this? So put this here. We draw a table. I draw a table. So we know the stationary point was at x is equals to 0. This is dy by dx, dy by dx. This is x is less than half at x is equals to half. And finally, x is greater than half. When x is equals to half, dy by dx is 0. When x is when x is uh when x is less than half, let's use x is equals to 0.4, then we get dy by dx is negative. And if we use x is equals to 0.6, we get dy by dx as a positive value. You can check this. And then finally, there's one more. We have to draw another segment of this table. We call this shape. Shape of curve. Now, if the curve, sorry, my bad, I made a mistake. Sorry. This would be positive, this would be negative, right? So, if the curve has a positive gradient, shape is like this. For stationary point, shape is this. For negative gradient, shape is like this. Therefore, we can deduce the shape of the graph is like this, which is a maximum curve. Therefore, we can say point is maximum. Okay, that's it. Okay, guys, that's all for today. I don't think I have anything more to teach. These are all the concepts that you guys will be needing when you guys start solving your question papers. And of course, there are unique cases that you'll find here and there, but I think I have taught you guys the most common, the most complex, and the most required concepts that you guys need. With this, wait, am I forgetting something? No, I don't think I'm forgetting anything. Uh, with this, I conclude this video, and I hope to see you guys in the next one. Inshallah, take care. And if you guys have any queries, please you can always uh write a comment down below or reach me via mail. Thank you. Take care. Inshallah. Bye bye. Inshallah, you'll do good. Bye.